So sorry that that video just stopped in the middle of this question. So what we were trying to find was the sample size. So n equals z times the standard deviation divided by the error, the entire thing squared. So my formula here, what I did was I got my z. So we looked it up on our table, and 90% was at 1.645. Population standard deviation, it told me it was 211. It told me I wanted it within 15 minutes, so that's an E of 15. When I do my calculation, it comes out to 535.4. One thing that you want to know is you always want to round up. So even though 4 does not round up, you always have to round up when you're doing sample size. So on this one, it's going to tell me a study of the ages of motorcyclists killed in crashes involves a random selection of 152 drivers. That means my N is 152. My mean age is 33.89. So my mean is going to be 33.89. Population standard deviation, 10.8. Population standard deviation is 10.8. And it's going to tell me to construct a 90% confidence interval. I'm going to use my Z table to look up my 90% on the bottom, 1.645. My error is going to be what? Z times my population standard deviation divided by the square root of n, which is 152. So 1.645 times 10.8 divided by the square root of 152. Make sure you follow your order of operations. Use my numbers as an example if you need to. And then the confidence interval, the mean minus that error and the mean plus that error. 33.89 plus 1.44 is going to be the upper bound. 33.89 minus 1.44 is the lower bound. 32.45, 35.33. There's my 90% confidence interval. Notice that the confidence interval limits do not include ages below 20. What does that mean? The mean age of the population will most likely not be less than 20 years old for this group. So the number of degrees of freedom for a collection of sample data is the number of sample values that can vary after certain restrictions have been imposed on all the data values. Remember, degrees of freedom for our t and even for our chi-squared in future, it's going to be the data set minus 1 is what we'll use. And which of the following would be a correct interpretation of a 99% confidence interval, such as mu is between 4 1/10 and 5 6/10? We are 99% confident that the interval from 4 1/10 to 5.6/10 actually does contain the true value of mu, our mean. So this is going to be our chapter 7. Have a great day.